We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in 2023 December. The question is related to the concepts of quadratic form from the section Linear Algebra. This question is from the part C, that is a multiple select question. There can be more than one answer, bearing question ID 704078. The given question is: consider the quadratic form Q of the triad x, y, z is equal to x square plus xy plus y square plus xz plus yz plus z square. Which of the following statements are true? We are given four options. Option 1, there exists a non-zero u belongs to Q cube, that is Q cross Q cross Q, that is a triad of the entries coming from the rational field. U belongs to Q cube such that Q of u is equal to 0. That means the value of the Q at the triad u is 0. Option 2, there exists a non-zero u belongs to R cube such that Q of u is equal to 0. Option 3, there exists a non-zero u belongs to C cube such that Q of u is equal to 0. These three options will tell you the existence of the non-zero triad from Q cube, R cube, C cube such that the value of Q at u is 0. Which one of them is true? Option 4. The real symmetric 3 by 3 matrix capital A which satisfies Q of x, y, z is equal to the row vector x, y, z multiplied by the 3 by 3 matrix A multiplied by the column vector x, y, z for all x, y, z belongs to the field of real numbers is invertible. That means, in other words, this is the matrix A is the matrix of the quadratic form Q x, y, z. And that is the option 4 says we have to show that whether A is invertible or not. Agreed? So let's now get into the solution of the question. We have the real quadratic form. Let's say this is the real quadratic form. X, y, z belongs to R cube. So Q of x, y, z is equal to x square plus xy plus y square plus xz plus yz plus z square. Agreed. Now let us write down this as x transpose capital A x, where capital X is the column vector x, y, z, and the matrix A is the coefficients of x square, y square, z square are along the diagonal, and the coefficient of xy is 1 divided into two equal parts. Write it in the 1, 2 position and 2, 1 position, half, half. Like that, the remaining entries are filled up. Right? So that is the matrix A. We continue in the next slide. This is what we have done. The most easiest one is the option 4. Option 4 is A is invertible. Is it so? That's what we have to see. So take this matrix A, find out its determinant, and if it is not equal to 0, then A is invertible. So take the determinant of A. So write down the determinant of the matrix A. So to evaluate this determinant, we perform elementary row operations on it. And by doing the elementary row operations on it, the determinant value is not going to change. So to make this position, that is 2, 1 position 0, so multiply the entries of the first row by 1 by 2 and subtract from the entries of R2. So R2 is R2 minus R half times R1. So also in this case R3 is R3 minus half times R1. Then this will become 0, this will become 0, these entries will change correspondingly. So this will be 1 half half 0, and this is half times half is 1 by 4. 1 minus 1 by 4 is 3 by 4. Half times half is 1 by 4. 1 by 2 minus 1 by 4 is 1 by 4. So in a similar fashion, this is 0, 1 by 4, 3 by 4. Now expanding this determinant by the first column, then it will be 1 into 3 by 4 into 3 by 4, 9 by 16 minus 1 by 4 into 1 by 4 minus 1 by 16, that is 8 by 16, that is 1 by 2, which is not equal to 0, and it is positive. So determinant of A not equal to 0 means A is non-singular, therefore A is invertible. So the option 4 is true. Agreed. Now we move to the next slide for the further discussion. So we recall two results here. First result is a real quadratic form Q of capital X is equal to X transpose AX is positive definite if Q of X greater than 0 for all X belongs to R cube, for all X not equal to 0, that means for all non-zero vectors X belonging to R cube, Q of X is greater than 0. That is the definition of positive definiteness. The other result is a real quadratic form Q of X is equal to X transpose AX, X belongs to R cube, is positive definite if all the leading principal minors of A are positive. What are the leading principal minors of capital A? The one minor, the leading principal one minor is 1 only, which is greater than 0. The leading principal 2 minor is the determinant 1 half half 1. This is 1 minus 1 by 4, that is 3 by 4, which is greater than 0. And the leading principal 3 minor is the determinant, the whole of the determinant itself, which we have already seen. It is 1 by 2, which is positive. So let's see. The leading principal minors of A are, the 1 minor is 1 greater than 0, this one. And the 2 leading principal minor is 1 half half 1, determinant is 1 minus 1 by 4, that is equal to 3 by 4 is equal to 0. And the leading principal 3 minor is the determinant of A. The determinant of A is here, and we have already evaluated this one, and we got the answer 1 by 2, which is greater than 0. They are all positive. The leading principal minors of A are all positive. Therefore, by the result 2, this quadratic form is positive definite. So the real quadratic form Q of X, X transpose AX is positive definite because all the leading principal minors of A are positive. Right. So now by the result 1, therefore Q of X, that is equal to X transpose AX, is greater than 0 for all X belongs to R cube, X not equal to 0. Because it is a positive definite, and that is a property by 1. So for all X belongs to R cube, X not equal to 0. Right. So let's look at our options. Our option 2 says there exists a non-zero U belongs to R cube such that Q of U is 0. You see, for all non-zero X, Q of X is greater than 0. For all non-zero X belongs to R cube, Q of X is greater than 0. Therefore, there does not exist a non-zero U belongs to R cube such that Q of U is equal to 0. Therefore, the option 2 is not true. Right. The option 1, so option 1, that means for all x belongs to q cube, is it going to be true? No. Now let us see. Suppose you take a x belongs to q cube. X belongs to q cube implies x belongs to r cube, because every 3 tuple of q cube is also an element of r cube. And when it belongs to r cube, this does not happen. Q of u is equal to 0. That's not true. So now q of x is equal to x transpose ax is greater than 0 for all x belongs to q cube when x not equal to 0, because q cube is contained in r cube. That means if x belongs to q cube, that implies x belongs to r cube. When x belongs to r cube, q of x greater than 0. So the option 1 says there exists a non-zero u belongs to q cube such that q of u is equal to 0. This is not true. So the option 1 is also not true. So far option 1 and 2 are not true, and option 4 we have already seen it is true. Let's move to the next option, that is the option 3. There exists a non-zero u belongs to C cube, a triad whose entries are complex numbers such that q of u is equal to 0. Right. Let's now take a q of the triad x comma y comma z is equal to the given one, and this is equal to x plus y plus z whole square minus xy minus yz minus zx. Now look at that, and can you think of a triad belonging to C cube? When you substitute, this is going to be 0. Yes, one can think of that one. X is 1, y is omega. Omega is the cube root of unity, which is a complex number. Z is omega square. So if you take that, 1 plus omega square is 0. And this is minus 1 into omega minus omega minus omega into omega square, omega cube, that is 1, minus omega square into 1, that is omega square. This is minus of 1 plus omega square, that's also going to be 0. So put the triad x comma y comma z is equal to the triad 1 comma y omega square, where omega is the complex cube root of unity, and this belongs to C cube. Then q of 1 comma omega square is 1 plus omega square whole square minus 1 into omega minus omega into omega square minus omega square into 1. So this is the property 1 plus omega square is 0, and this is minus omega cube is minus 1 minus omega square. This is minus of 1 plus omega square, that is equal to 0. So there exists a non-zero u belongs to 1 comma omega square belongs to C cube such that q of u is equal to 0. Yes, the option 3 is true. So therefore the option 3 is true. And we have already seen that option 4 is true. So in all, the answer to this question is option 3 and option 4. And that is the detailed discussion of the solution of a problem from topic quadratic forms from the section linear algebra. I am sure that you have understood the solution of this problem. If you like my videos, please like, share and subscribe my channel. I wish you all the best. Thank you.